So first, I'm going to start with the introduction, the background of study. First is origin in 19th century. BMI or body mass index was developed in the early 19th century as a measure to assess body weight relative to height. Next is Quetelet index. Named after Adolphe Quetelet, the formula was initially devised in the 1830s, providing a standardized metric for weight assessment. Third one is 20th century prominence. BMI gained widespread recognition in the latter half of the 20th century, coinciding with growing concerns about obesity and its associated health risks. Next, WHO adoption. The World Health Organization (WHO) adopted BMI as a universal tool in the 1990s, solidifying its role in public health assessments. Next, formula. BMI is calculated by dividing a person's weight in kilograms by the square of their height in meters. Next is category. BMI categorizes individuals into distinct groups such as underweight, normal weight, overweight, and obesity based on calculated values. Continuing with the background of study, limitations. Despite its prevalence, BMI has limitations as it doesn't consider factors like muscle mass, bone density, or other components influencing body composition. And last but not least is screening tool. Despite limitations, BMI remains a practical tool and accessible screening tool, contributing to discussions on the relationship between body weight and overall health. To continue with the introduction, let's move forward to objectives of study. First, this study is to determine the relationship between the BMI of the students in the Faculty of Science and how much they weigh. Next is to obtain the types of graph that is suitable for the data. The third one is to find the values of mean and standard deviation of the data. Next, to determine correlation and regression of the data, and last but not least, to fit a straight line based on the data. Now let's talk about the significance of study. The data that we use for this study is a secondary data. So, secondary data is easy to access because first, it is available on Kaggle website. Next, it is much more time, energy, and money saving because we don't have to analyze, interpret, and collect the data on our own. The third one is it is less costly than primary data. Besides, it is also more accurate than primary data because the values are obtained rapidly. And last but not least, it is a more stable data compared to primary data because it is done by researchers instead of ourselves.
Next, we move to methodology. There are variable, type of variable, and level measurement. Variable for weight of student is independent variable and type of variable is quantitative continuous, where the data can be represented, and level measurement is ratio scale. Variable of BMI of student is dependent and type of variable is quantitative continuous, and level of measurement also ratio scale.
There are three graphical techniques in this report, which is the first one, scatter plot. In this graph, variable x is weight and for variable y is the BMI. Scatter plot is used in this to find the possible relationship between two variables in a dataset. Not only that, it is also used to identify correlation. Second one is the fitted line plot. Same as scatter plot, variable x is weight and variable y is BMI. Although it is similar to scatter plot, but it has regression line which show its regression equation. The last graphical techniques used in this is histogram. There are two histograms used in this report, where the first histogram shows that variable x is BMI and the second histogram shows that variable x as weight. This is because to represent the frequency of numerical data.
In numerical technique, we have 6 techniques, which is mean, median, quartile, variance, standard deviation, and coefficient of variation. The first is mean, represent average value. Next is the value that present the middle point. For quartile, we have first quartile or lower quartile and third quartile or upper quartile. Next is variation for estimate the average difference between the measurement. And last is coefficient to measure of dispersion of the data point.
For the data representation, we found that the weight of the student is the independent variable and their BMI is the dependent variable. Both of these variables is quantitative data. The data shows that BMI depend on the weight of the student. This show objective for this report, which is to investigate the relationship between weight and BMI.
Descriptive statistic analysis based on the histogram graph which represent the BMI of student in science faculty. The highest BMI is 25 kg per meter square and below, and the lowest BMI is about 15 kg per meter square and above. The histogram indicate that the distribution is negatively skewed. This means that the distribution is skewed to the left. The value for the mean and standard deviation are 21.8077 and 2.6371 respectively, while based on the histogram for the weight of student science faculty, the highest weight taken is 110 kg and below, and the lowest weight is 20 kg and above. The histogram indicate that the distribution is positively skewed. This means that the distribution is skewed to the right. The value for the mean and standard deviation are 62.81 and 25.0005 respectively. For descriptive, as shown in the table above, the minimum and maximum value for weight for student of science faculty are 28 kg and 104.8 respectively. Hence, the minimum value for BMI in the science faculty is 15.7263, while the maximum value is 24.3902 kg per meter square. Correlation and regression. For the scattered plot, it is a positive correlation between the weight of the science faculty student and their BMI. For correlation, the value of R, which was 0.917, suggests a moderated correlation between the weight of science faculty student and their BMI. That is, the heavier someone from the science faculty weight, the highest their BMI. For regression, the coefficient of determination, which was R square, means that 84.4% of BMI can be explained by the weight of science faculty student, and the remaining is unexplained variability in the BMI. R value suggests a moderated correlation relationship between the weight and the student BMI in science faculty. The regression equation was like shown in the slide, and the slope B means that for every increase in weight for someone in science faculty, the BMI will increase by 0.097. Last but not least, fitting a straight line. We can interpret this slope by, if there is additional weight for the science faculty student, the BMI will increase by 0.097. As I said before, as for the intercept, if the weight of the science faculty student is 0 kg, the BMI prediction is 15.73 kg per meter square.
Last but not least is the report summary. For this data, the dependent variable is BMI and the independent variable is weight. The relationship between weight and BMI of a person shows a positive correlation. A weight of a person has an impact on their BMI. Students with heavier weight have higher BMI. Its correlation value is 0.916, which suggests a moderate correlation relationship between weight and BMI. Based on the regression equation, for every increase in weight, the BMI also will increase by 0.016.